Hi, so in this video we're going to talk about the Vernier caliper and reading in metric. So the components of this tool are still the same as if you were reading it in imperial. I can still read the outside diameter of a component. I can read the inside diameter of a component. I can read the depth of a component, and it reads both imperial and metric. So definitely a benefit of using a Vernier caliper. Unlike the imperial, the metric has a lot fewer steps and easier for most people to learn to read. On this specific Vernier, the metric scale is on the bottom half here. So this is our scale down here, our fixed scale, it doesn't move, where this is the Vernier scale that moves up and down. So I have it locked into a measurement right now. If you look at the bottom down here, it's also indicating that this is the bottom half, has the millimeters up down at the bottom, and then you have inch up at the top or inch up here on the Vernier scale. This one is indicating 0.02 millimeters. That is telling me that each one of these little lines on the Vernier scale represents 0.02 of a millimeter. Now looking at my fixed scale here, you will notice there's a 1, there's a 2, there's a 3, there's a 4, and it continues on. So each one of those represents 1. So this is 1 centimeter, this is 2 centimeters, 3 centimeters. What we want to do is convert this into millimeters. So each one of these little lines here represents 1 millimeter. So as an example, just put a 0 beside it. So if it was 1 and there's a 2 here and then there's a 3 here, all you want to do is add a 0. So that's 10 millimeters, 20 millimeters, 30 millimeters as you continue through. So what we want to do on this one is to measure in the metric scale on this Vernier caliper. Again, remember that the bottom scale is our metric spot, and just like before on the imperial, we're using this 0 line on the Vernier scale as our starting point. So what does this 0 line pass on my fixed scale? What we're looking through is I count up each line as we go across, and I've passed the 25 line. I'm actually in the middle of the 25 line and the 26 line. So just like before, keep yourself kind of a count as you go through. So I have 25 millimeters. So I have my 25 millimeters. Now, because that 0 line is in the middle of my 25 and the 26 line, I have to go across this Vernier scale and find which line matches up. So which one of these little tiny lines, those lines, remember I mentioned, are worth 0.02 of a millimeter. Which one of these little lines is the first line that matches perfectly with one of the lines on my fixed scale? It is very hard to see, and once you are using the tool, it's a lot easier to get used to using it. But as we followed along this path here, I will notice that my first line that lines up perfectly on my fixed scale is the number 6. Now remember, each one of these little lines represents 0.02. So basically 2, 4, 6, 8, 10, 12, 14, as we continue on. So that is so 0.60. All we want to do is add them together, so I have 25.6 millimeters. And that's how you read a metric Vernier.